Hello, my name is Tina, and the presentation that I prepared today will cover a method of high-rate clarification. So before diving into details, first let's define clarification and what exactly it does. So clarification is a process in a conventional treatment plant with the purpose to decrease solids concentration after coagulation and flocculation has transpired. It's a term that's typically used interchangeably with sedimentation. So you'll hear that certain sedimentation basins are referred to as clarifiers. These two terms are different, but they essentially do and accomplish the same thing. So here's a little refresher on conventional municipal water treatment units. Obviously, influent water comes in and it goes through coagulation, flocculation, sedimentation / clarification, filtration, disinfection, and then it is discharged as effluent water into a water body. Now, the reason why I bring out this process layout is because throughout this presentation, you'll see how using certain unit operations can change this layout by combining some of these features and processes. So we have two main categories of clarifiers. We have type 1 clarifiers and type 2 clarifiers. Type 1 clarifiers are conventional sedimentation basins. So they're very basic, very plain sedimentation units, and these are typically placed after flocculation. And then we have type 2 clarifiers, which combine both flocculation and sedimentation into one unit. So in this presentation, we'll focus on type 2 clarifiers, specifically contact clarifiers. So to understand contact clarifiers, we need to know what high-rate clarification is. High-rate clarification refers to all processes that can be loaded at a higher rate than typically used in designing conventional clarifiers. So some examples include tube and plate settlers, dissolved air flotation, and contact clarification. And here are just some photos of each. You can see that they all look drastically different in appearance, but they essentially accomplish and do the same thing. So now let's get into contact clarifiers. These operate in two zones. The first zone we have is mixing. And in this segment, the source water or influent water is taken in where it's mixed and treated with chemicals and coagulants like metal salts and polymers to kind of promote that thickening effect of the contaminant particles. And this happens in a rapid static mixer, usually. And then we have the second zone, which is a settling zone. So this is where the chemically treated influent water is directed upward through the sludge blanket. And the sludge blanket acts as a filter by essentially trapping the floc while the clarified and treated water continues upward. So contact clarifiers combine the process of chemical mixing, flocculation, and gravity sedimentation in a singular tank. So if we recall back to the map layout of a conventional municipal water treatment plant that I had earlier, you can see how using a contact clarifier can change that layout by combining the flocculation and sedimentation processes into one unit. Also, with influent water that has low turbidity, color, iron, and manganese, contact clarifiers are most efficient. With this type of water quality, contact clarifiers can be economically optimal compared to other types of clarification methods. So contact clarifiers require no mechanical equipment to remove solid residuals either. So here's a pictorial depiction to showcase the way that a contact clarifier works. So in this diagram, you can see the influent water coming in and the chemicals being fed into the mixing zone as well. So influent water and chemicals interact here. Afterwards, when flocculation occurs, the contaminant particles undergo that clumping and thickening effect, and it forms the sludge blanket at the bottom of the tank. So here you can see the clarified and treated water rising upward and the sludge blanket remaining down at the bottom where it is imminently removed. Also in this depiction, you can see the mixing zone and the settling zone mentioned precedingly. So again, here in the mixing zone, you have the chemicals in the influent water interacting, and outside in the settling zone, you have clarified water and the flock separating. Here's a GIF I found online to kind of pull all of the details and designs together so you can kind of see how big a contact clarifier can be. So sledge removal is a very important process of clarification, and for contact clarifiers, the solids that are formed must be removed either by washing or flushing. So the cleaning cycle starts off by closing the effluent and influent valves, and then the media is air scoured. So if the media is buoyant, it typically just undergoes air scouring. However, if it's non-buoyant, it will undergo a combination of scouring with both air and water. Excuse me. Afterwards, for buoyant solids, the air is turned off, the waste drain valve is closed, and the effluent valve is opened. And for non-buoyant solids, the water is maintained for additional time to flush the solids. So both of these cycles for buoyant and non-buoyant solids require a very similar total wash time. A relevant value to consider for contact clarifiers is the surface loading rate, because that's what the design criteria is rated based on. So contact clarifiers typically operate between 8 to 10 gallons per minute per square foot, or 20 to 49 meters per hour. Contact clarifiers can also effectively operate at up to 150% of design flow rate in certain cases. So higher flow rates can be considered, but obviously only after regulatory approval, because you still want to ensure that the clarifier will function properly. So contact clarifiers are very common in treatment plants, and here are some reasons why. We have a shorter detention time, less chemical consumption, faster flocculation, and less space requirements when contact clarifiers are used. A few disadvantages include how sensitive the unit is to rapid changes in water temperature and fluctuations in flow. So changes in either of these variables could disrupt the function and the sludge blanket within a contact clarifier. So what can contact clarifiers be used for? They can be used for several different functions, like surface water clarification, removal of heavy metals from industrial waste, phosphorus removal, lime softening of groundwater, and it can be pretreatment to conventional filtration. All in all, contact clarifiers are viable unit operations that are commonly used in treatment plants due to their favorable attributes mentioned throughout this presentation, such as only needing one unit for flocculation and sedimentation, having a lower chemical demand, and requiring no mechanical structure for sludge removal. And because of these things, there are considerable savings in tankage and maintenance and overall operational costs. So that essentially concludes my presentation on contact clarifiers, how they operate, some pros and cons, and their functional uses. Thank you for your time and attention, and have a great rest of the day.